Sure.
Yeah, Billy.
Could you do 19?
Sure. So 19, the directions ask us to use long division to do this. Even if it didn't, I would recognize that the divisor is not a linear polynomial. It's a degree 3 polynomial, so I know right away that I'd have to do long division on this. When I take a peek real quick at the divisor, I notice I go x cubes and then to x's, and I skip the x squareds. I'm going to go ahead and add in a 0x squared. And really, I'm going to do that anytime I notice that I have a missing term. And that just helps to keep everything lined up. For long division, you don't necessarily have to do that, but boy, howdy, it makes life quite a bit simpler if you remember to put those zeros in. And then I'm going to do the same thing for the divisor, or for the dividend, the numerator. I notice again I'm skipping the x squared, so I'm going to make sure I put a 0 in there. So there's that. Now I'm going to ask myself, what times x cubed gives me 4x to the 5th? It doesn't really matter. 4x squared. And yes. And the 1 and the 4 multiply to give us 4. So that it's on top of the other x squareds. That's usually all I'm trying to do is just make sure everything lines up nice. Okay, so now I multiply that to everything in the divisor. I write it underneath, and then I'm going to subtract down. So where did I get the what? Okay. Now, I never think about these as subtraction problems. I want to think about them as addition. So I'm going to distribute that negative through and rewrite it as an addition problem. So 4x to the 5th plus a negative 4x to the 5th is 0. 7x to the 4th plus 0x to the 4th is 7x to the 4th. 1x to the 3rd plus negative 4x to the 3rd is negative 3x to the 3rds. And then 0x squared plus 20x squared is 20x squared. And then I'll bring everything else down. And then I'm going to repeat again. I'm going to ask myself, what times x cubed gives me 7x to the 4th? 7x. Everybody agree? I'll then distribute that. And then subtract down. But again, I don't like to think about these as subtraction problems. I want to think about it as addition problems. So I'm going to distribute that negative through.
That's just flip side.
Correct. Yep. So 7x to the 4th plus negative 7x to the 4th is 0. Negative 3x cubed plus 0x cubed is negative 3x cubed. 20x squared plus negative 7x squared is 13x squared. Negative 8x plus 35x is 27x. And then I'll bring that one down. And then I'll ask myself, what times x cubed gives me negative 3x cubed? Negative 3. And then I'll multiply that to everything over here. And then we'll subtract down. Again, I don't like thinking about this as subtraction. I'm going to create it or distribute the negative through and make it an addition problem. Come on. Negative 3x cubed plus 3x cubed is 0. 13x squared plus 0x squared is 13x squared. 27x plus 3x is 30x. And then 1 plus negative 15 is negative 14. And I know that all this stuff at the end is my remainder. And I know that because I got to the linear term right here. Right? So my final answer, we would say that this rational expression is equal to my quotient plus my remainder over my divisor. Joey? If you left out the 0x squareds in your final answer, that would be okay. Not necessary to include them. Fine if you do. Alondra? 50, 50. Okay. All right. So if I look at 50, first thing I can do is by the fundamental theorem of algebra, I know I'm looking for 4 zeros. My possible rational zeros are going to be of the form the factors of 64 divided by the factors of 1. So my factors of 64 are 1, 2, 4, 8, 16, 32, and 64. So I'm going to now type this into my calculator and take a look at what I have. So I'll type that into my calculator. I'm going to reset my window from negative 64 to positive 64. Please stop talking. Hit graph and take a look. All of my action looks like it's in here, real close to the x-axis. So I'm going to resize my window and maybe just go from negative 2 to positive 2. That probably covers everything. Oh, I guess I will do negative 4 to positive 4 because I want to see if those are bends or bounces or whatever. So those both look like they're going straight through at 2 and negative 2. So it looks like I have 2 real zeros that I can see, but I'm supposed to have 4. Where are the other 2? They got to be imaginary then, right? All right. So let's get looking for these guys. So I'm going to start my synthetic division. I'm going to start with negative 2. What are the numbers that are going to go inside my synthetic division piece? This is probably where we made our mistake. Yeah, what are the zeros for? There's no x cubed, and there's no x. We're looking at the coefficients there. The coefficients on this polynomial. 1 is the coefficient on the x to the 4th, and then 0 on the x to the 3rds, because there's no x to the 3rds, and then 12 on the x squareds, and then 0 on the x's, and then negative 64 on the 1s. Landra, so far so good? Okay. We do that. So that worked. But what we're going to get there is a cubic. So we're just going to keep going. So you said you lost me, and then some mumbles happened, and I stopped to listen, and then I didn't.
So why do you keep going?
So this answer right here is going to represent a cubic polynomial because I had a degree 4, and I divided it by a degree 1, so I'm going to get a degree 3 back. We don't have any formulas to deal with a degree 3 polynomial, so I want to keep going to get to a quadratic. So I just took my answer and then continued to do another synthetic division. It's the coefficients from the problem, right? So, because dividing by negative 2 gives me a remainder of 0, I know I have an x plus 4 factor. Because dividing by positive 2 gives me a 0, I know I have an x minus 2 factor. And then what's left, constant, x coefficient, x squared coefficient, I have x squared plus 16. There's my factored form. I'm now just going to set this equal to 0. Apply the 0 product property. So negative 2, positive 2, I knew that. To solve x squared plus 16, I could use the quadratic formula, or I could solve this directly. I'm just going to solve it directly. We'll subtract the 16 over. Square root both sides, close. So I get plus or minus, but it's a negative. I'm squaring a negative, so I get a I. And the square root of 16 is 4. No, but for the test, yes. Mhm.
What?
Yeah.
Wait. Oh. So like, does that mean? Okay. So. Really? So wait. Oh my god.
Mhm.
The psych test. Okay. So like,
Choice.
It's not even on this, but like when you do the long division, you said it doesn't matter where you start. So, like,
Where you write your quotient? No, it
like
doesn't.
if you started like more to the left,
I would not make any deduction.
like if you were bringing down more stuff, like,
Uh, what I'm saying is, like, if you write 4x squared here, that's fine because you're still going to write that part right there, and everything is still like, right? Like where you put the 4x squared up above, I don't care. I try to line it up so that like all the degrees line up vertically. But like if you didn't do that, it's not wrong.
yeah.
What matters is that you get the right thing here and here. Does that?
Yeah.
Okay. Yes.
Will we have time to work on half sheets after the homework quiz?
Yes.
No, we'll never.
Alondra.
What's the latest with
I mean, tomorrow would be fine, I guess.
Yeah, but ADHD is the level.
All right. Clear your desks.
Yeah.